Today my topic class ninth, because before this video I explained about the number system in which types of number and some operations already we discussed in the previous video. But in this video we discuss about the operation on real numbers, because I also explained about the real numbers. All numbers including in real numbers like natural number, whole number, integers, rational number and irrational numbers. So before of this we explain about the rational number operations, like sum of rational number, between rational numbers you find out, represent rational number on number line, also represent irrational numbers on number line. But now, especially on operation on real number, here we have a topic of irrational numbers, because irrational number we know that like all square root terms, all cube root terms, they are including in the irrational numbers. So there are four operations we have in the irrational number. First is like addition, subtraction, multiplication, divide. Okay, because these four operations, they are the basic operation of mathematics. And now here we introduce what do you mean by the irrational numbers. Like root terms you show out like root 2 and root 3. Okay, this numbers you write down in the square root. So what do you mean by the root? If no numbers are down here, that is a root. It means suppose this given form in the radical you represent in form of the exponential, then to the power 1 by 2. Okay, every root sign shows their power is 1 by 2. Similarly here root 3, it means 3 to the power 1 by 2. Similarly, but here 3 and then 2 is given, it means 2 to the power 1 by 3. So this is the power of this radical sign. Like suppose n power is given and then the root of 2, it means 2 to the power 1 by n. So this is the root, shows the root. No number is given here, that is you already consider that is a 1 by 2. And number is given, then you take like 3 here, so you take 1 by 3. N is given, then you have 1 by n, and then so on. So many properties are here. So this is the concept of rational numbers, and this is also called surds. Especially here this words short by this type of terms like surds. So first here we introduce about the surds. Surds means you represent the number in the radical forms like a symbol, square root sign, cube root sign, fourth root, fifth root, and nth root are given. And now some operations they are related with the surds, because some basic operation we start, then we find out addition, subtraction, multiplication, and then divide. So before this, first I understand the concept of the rational numbers. If they are given in form of the square root, maybe given in form of the cube roots. So first you know the concept of in exponential form. If numbers given in the root, then how you represent in form of the exponential terms. So that is very easy. And I also here I explain about their power, how you represent. So there are two basic terms here we discuss: pure surds and mixed surds. So what do you mean by pure surds and what do you mean by the mixed surds? Then we go on the operation. After first here we explain about the pure surds and mixed surds, then we go. Okay, then here we write down 2 root 3. 2 root 3. Okay, so 2 is a multiple of this root sign. And now here this is the power. Power means inside a small number is given. Okay, so here 2 root 3, it means this is a mixed surds is given, and now you can convert into the pure form of this surds. So depend on here root. If no root sign is given here, then you consider as a 2. So this 2 you convert into inside, then here you multiply 2 times if you want convert into the pure surds. So this 2 inside taking, then 2 times you multiply, then 3 to the 6, 6 to the 12. So 12 is a pure surds. Okay, then we have the example for 3 root 2. So now this 3 inside comes how many times? 2 times, so 2 3 is 6, 6 3 is 18. So 18 is a pure surds. And now again we have the another example. like 4 root 3. So how you convert 4 root 3? Means first you include this 4 inside 2 times multiply with the given number. So 3 into 4, 3 4s are 12, 12 4s are 48. So this number is 48, then this is converted into the pure search. And now again we have the fourth example like 2, but here cube is given and inside number is 3. So what do you mean by this? 2 cube root of 3. 2 cube root of 3 is you want to convert into the pure search, then this 2 inside multiply 3 times because its power is 3. So you write down as it is, power 3 you put as it is here, 3 as it is, and outside value you put inside. How many times depend on its power. Power is 3, then you multiply 2 3 times inside. So your pure search is now here 3, then 3 to the 6, 6 to the 12, 12 to the 24. So your answer is 24. So that is very easy concept. You convert any square root term into form of the pure search. Always you put outside value you put inside, depend on their power. If power is 2, then you multiply inside 2 times. If power is 3, then you multiply 3 times. Okay, we take another example like fourth. Here we have suppose 2 and here write down 4 and then 2. Now power is 4 and now again you can convert into the pure search. Then you put power your 4 as it is, 2 as it is, and this 2 you put inside how many times? 4 times you multiply inside. Okay, this 4 times you multiply inside, then 2 to the 4, 4 to the 8, 8 to the 16 and 16 to the 32. So 4th root of 32 is the answer. So any type of questions you can try, you convert into the pure search. That is only one thing is important. Outside value you multiply inside, but depend on its power. If power is not given, means you multiply 2 times. If power is given, then depend on the power. If power is 3, you multiply inside 3 times, 4 times, depend on the power. Okay, then now second phase is what? You convert into the make search. Okay, so now start from the second example like make search. Okay, now start for make search. Okay, you have suppose 18, like start here 18. Okay, and then you convert 18 into the make search. So first you find out the prime factor of 18. 2 9s are, 3s are, and then 3 1s are. Okay, so write down all factors inside. Okay, depend here what is given. No term is given means 2 is already here. So if numbers are in pair, so 3 in pair, so 3 is outside and then 3 root 2 you have. So that is you convert into the mix search. Every number if they are inside, then you taking outside. Depend on power here you put outside. Similarly we have another example like root 27. Okay, then again you find the prime factor of 27. 3 3s are and 1s are. So you write down all factor inside. 3 into 3 into 3, and now we have the pair of 3. So this is outside. You have 3 root 3. But now same question we have, but power here 3 and we have 54 inside. Now not square root is given there. Now cube root. So what do you mean by cube root? We find out the prime factor first, and then 2 2s are. Okay, then 2 7s are, 3 9s are, 3 3s are, and 1s are. Okay, so you write down all factors 3. So you have 2 into 3 into 3 into 3. Now your power is 3, means all inside numbers first you check out. If they are all digits, if they are 3 times, you underline they are all 3 times. Okay, then this terms is outside. but you add on one digit one time here, and then this is 3 cube root of 2. Okay, so your answer is 3 cube root of 2. So in this way, in this process, if a number makes inside is given, and then you can convert into the very easy form. So first you understand before of operation addition, before of operation subtractions, before of multiplication, before of division. Operation on real numbers. Now first here we use the concept of addition, like because basic operation there are four: addition, subtraction, multiplication and division, in which we start first addition. Sum of given numbers, as an example here we illustrate like how you add the given irrational numbers. Okay, then here we consider 2 root 3 plus 4 root 3 and 5 root 3, because all square root numbers are same here, root 3 root 3 root 3. And then how you add, because all sign here plus is given. So now according to the like term and unlike terms, if you have suppose the algebraic expression, then some terms they are given in form of the x, some terms they are given form in the y and z, and then we separate out the like terms. But here there is no requirement for the separation of like term or unlike term, because all terms are like, every term having root 3 root 3 root 3. So that is very easy concept. You taking outside root 3 and rest of the value you put inside in a bracket. 2 plus 4 plus 5 is remaining. So concept is what? If you add the irrational numbers, then you use the concept of bracket. You keep out a square root term outside, and all integers you put inside. Maybe they are outside value like 2, 4 and 5, here we put as it is. So your value root 3 you put as it is. Now 2 plus 4 is 6 and 6 plus 5 is 11. So you add on 11 and now your answer is 11 root 3. Okay, so this is clear now. And now but all outside value is given an integer, here some fraction also given, but square root terms are again same, root 2 root 2 root 2. So you put outside root 2 and then inside value is 1 by 2 plus 3 plus 4 by 3. Okay, so again we use the concept of bracket. We keep out the value like root 2 here having all terms, so we put outside, and rest of the value you put inside in the bracket. And now one term is integer, so we convert it to the rational number, so we put 1 in upon here, then taking the LCM of 2, 1 and 3 is 6. So LCM is 6. Now you write down root 2 as it is, and then you are taking the LCM as 6. So operation is 2 3s are, so 3 here and 6, so 6 3s are 18, and now 3 2s are, so 2 4s are 8. So 3 plus 18 is 21, and 21 plus 8 is 29 upon 6. So there is no simplification is required, because 29 is prime number. So 29 by 6 root 2. Okay, so you got the answer 29 by 6 root 2. Okay, after simplifying you got the answer. Similarly, we have another example like, but here we have the different situation now. In both the equations we have the same term, all terms are like terms, but here root 2 and root 2, root 3 and root 3. There are two terms. So the concept of like term and unlike term you use here. First you separate out the like terms, because there are two terms for root 2 and there are two terms for root 3. So first here we separate out the like terms, 3 root 2 and 2 root 2. Okay, both terms you separate out now. Here you have 4 root 3 and 6 root 3. Okay, here separate both because they are mixed given, but concept for addition you use the concept. You separate out the like terms and unlike terms, because then addition is very easy. So you taking out root 2 common, and now you have 3 plus 2. Here root 3 is common, and then you have 4 plus 6. So 3 plus 2 is 5, and here root 3, 4 plus 6 is 10. So answer is 5 root 2 plus 10 root 3. Okay, then answer very easy. The concept is same again. Concept is what? You separate out the like terms. Again we have another example that is same again. Again you will have the two types of terms like root 5 and root 2. So first here we underline the root same terms. So this 4 root 5 and 1 by 2 root 5 is same. So you separate out first 4 root 5 and then plus 1 by 2 root 5. Okay, similarly you have root 2. So you put first 7 root 2. Similarly you have again the same term 3 by root 2. Okay, so you underline the like terms. These two terms are same, these two terms are also same. But inside value root 5 is same, but outside value, that is one integer and other is rational number is given. Now concept you use the same again, you taking root 5 as outside and inside value 4 plus 1 by 2. And then similarly you again taking out root 2 here. So root 2 and then last value is 7 plus 3 by 2. So you put 3 by 2 here. But again you put 1 here, you convert it to the rational number, and then there are two options now you have here 2 and 2. So your LCM is 2 because you have the single number. Now 2 as it is, 2 4s are 8 plus 1, and similarly root 2 you again have the LCM is 2, so 2 7s are 14 and plus 3 here, so 8 plus 1 is 9. So your number is 9 by 2 here, and then plus root 2 17 by 2. So your answer is 9 by 2 root 5 and plus 17 by 2 root 2 is final answer. So now, okay, this concept is very easy, operation is very easy. Only you take the LCM and then you got the answer, because we have the different category of questions. Here we have the like all term outside terms, here we have the integers, here we have the mixed question like rational and integers, and then we added. So both examples are different, both have the same content here, root 3 all having the same. So like terms are given, then how you add. If like terms are given with the rational numbers, then how you add it here. Similarly these two examples are also same. And now we go to the another example, like it is also a different part. Now you have root 12 and root 27. Because we know the concept of pure sets and impure mixed sets. This both numbers first we find, because they are not both questions are given but not in form of the mixed fraction. So first we convert into the mixed sets. So first we find out the prime factor of both the numbers. Like you write down the format of prime factorization number. 2 6 are 12 and 2 3s are, you have 3 1s are, and similarly you have 3 9s are and 3 3s are and 1s are. Okay, so you write down the inside, you have 2 into 2 into 3, and then similarly you have 3 into 3 into 3, and now you making the pair. Which number is common here? This pair is common. Okay, so taking outside, this 2 is outside, so 2 root 3 you have, and similarly here you have 3 root 3. So now again, what is this? This is a common number, so root 3 is common, so rest of term 2 plus 3, and then root 3 you put as it is 5 here, so your answer is 5 root 3. So now it is very easy going, because before of this root 12, root 7 is not possible if they are added, but after simplify, this operation is very easy, because now your number they are in form of the pure sets, but you still convert into the mixed sets, and then your number having some numbers are common, and then after simplify you have a single digit number. Okay, the same question is given here again, but here 3 pair of numbers are given, and like this root 3 you have a single number, so this is the mixed form. But 48 is not mixed sets. Now you convert 48 first, you convert into the mixed sets, and now 27 we have already here, so we use the concept of this, and now you put as it is. So first you find the factor of 48. Okay, so 2 24s are 2 12s are 2 6s are 2 3s are, and then 3 1s are. Okay, and again if you want to find out for factors of 27, then you use the concept of same and you write down the factors. Now you put as it is 1 by root 1 by 3 of root 3 and then plus root 48. You write on all factor inside here. Okay, then next term 2 by 3 and root 27 means 3 into 3 into 3. You put 3 times. And now you underline the pair. This pair and this pair. Similarly, you have one pair here only because second pair only of the single digit. But here there are two numbers that are in pair. So you're taking outside now. So one pair of 2, second pair of 2 you put outside, 3 as it is. And now 2 by 3 you put outside as it is, but one pair of this digit is outside 3 and rest of number you put inside this 3 is cancel out. And now 1 by 3 of root 3 and 2 to the 4 root 3 and then plus 2 root 3. So now again the concept is same. You taking outside root 3 because root 3 is common number and then plus 4 plus 2. So 4 plus 2 is 6. So you have root 3 and 1 by 3 plus 6. So 3 6 are 18. 18 plus 1 19 by 3 and root 3 is the answer. So you can this operations very easily because you have the mixed fractions terms, then operation is easy. But some numbers they are given in form of the pure surds, so pure surds you convert into the mixed surds, and then which number is common, which value is common, you taking outside of the bracket and then simplify the bracket, you got the answer. So now we go the operation for subtraction. Okay, now we have the operation for subtraction of rational numbers. Here we have some examples for subtractions. The process is same in addition and subtraction, but only one concept is there. First, you see the question. If like terms are given there, then there is no change in the operations. You proceed same. Like in this question, we have the root 2. So now operation is very easy. This number you taking common root 2 and now you have 3 and now here you have minus 6. So root 2 and 3 minus 6 is minus 3. So answer is minus 3 root 2. Okay, so operation is same again. Addition and subtraction, there is no too much change the operation, like you have the same condition. If addition is given, you add the number. If subtraction is given, then you subtract the number. Okay, then now we have again root 3 here. So root 3 is common and then 4 minus 1 by 2. Fraction is given. So you write down the LCM. LCM is 2 because single number. So directly here we have the LCM. 2 4s are 8 and minus 1. So 8 minus 1 is 7. So you have 7 by 2 root 3. And then again root 5 is common. So you put root 5 outside. And 3 by 2 minus 1 by 2. Okay, so again your LCM is same because both numbers are common in denominator. So 2 then 3 minus 1. So root 2 root 5 and now we have 2 by 2, that is cancel out. So your answer is root 5. Okay, so that is very easy. If you have the fraction numbers, then you are taking LCM and then after simplify you got the answer. Similarly again this question having the fraction, like both is different and one is common root 7, so you put again same common and then rest value you write down in bracket, and now again you have the LCM. Your LCM is 5 and then 3 minus 2, so you have root 7 and 1 by 5, so answer is 1 by 5 root 7. Okay, then here we tried some examples. They are related with the addition and subtraction. So we see here like your addition is very easy and subtraction both are the same operation, only your calculation part is different. But one major part now in the next operation, multiplication, is very different because there are operation may be changed, but addition and subtraction both operations are same. So now we continue. You try some examples with addition and subtraction and then we go on the next operation like multiplication. Okay, then we next operation is multiplication. Now Yeah, we start the how we multiply the given irrational numbers. We start from the example like you have root 2 multiplied by root 3. Okay, so multiply. If you multiply, then there first you find out their powers are same or not given here. Like root and root, not cube root is given. So both have the same symbol. Then multiplication is very easy. You multiply now this number inside, like root 2 and root 3. Like you have single root 2 into 3. So you have root 6. Okay, then we take the another example like suppose you multiply root 2 by root 8 and then you have 2 into 8. It means 16. Okay, and 16. And now you find out the factors. If any term is common there, you have 2 into 2 into 2 into 2. Now you have the pair. Okay, so 2 into 2. So your answer is 4. Now root is over because you have the complete numbers in the pair. Okay, so now it is a rational number. Now, not irrational numbers. So you suppose you find out or check out the given number is rational or irrational. So then you find out first you convert it into the mixers and then you check out if root is remaining there, then it is irrational. If root is over there, then you have the rational number. Like this question having after multiply it is a rational number, but before of this two numbers are irrationals. So after multiplication is converted into the rational numbers. So now we go again another example like 3 root 2 and multiply by 2 root 3. Okay, so outside number you multiply outside and inside number you multiply inside. Now outside is 3 and 2, so you write on outside 3 into 2 and then you have root. So inside value of root is 2 and here you have 3, so 2 into 3. So your answer is 6 root 6. Okay, so now again we have another example. 4 root 12 multiply by 3 root 2. Okay, so again outside value multiply outside 4 into 3 and then inside value here 12 and here 2, so 12 into 2 and then 4 3 are 12 and inside value is 24, but you simplify this term. So again you write down the factor of 24 is 2 into 2 into 2 into 3, but here 2 have the pair, so 2 is outside, so 12 into 2 and inside number is 2 into 3 is 6, so you have 24 root 6. Okay, so in multiplication both the operation are maybe you consider after simplify or before simplify. If only you multiply then your answer is 12 under root 24, but after simplify you have 24 root 6. So both answers are possible, but in suppose question is for only you multiply, so you write down your answer is 12 root 24, but write down your answer with simplify, then you write down 24 root 6. Okay, then we have another example like you have the pair of this 2, you have root 2 plus root 3 and multiply by root 2. Okay, so you have the pair like one bracket having root 2 plus root 3 and outside value is root 2. Now you multiply inside then root 2 into root 2 plus root 2 into root 3. Okay, and now both are same. So you write down inside like 2 into 2 and similarly you write down here 2 into 3. But here making pair, so your answer is 2 and now you have here 6. Okay, suppose you have the pair, then your roots are removed there and then if it is not forming in the form of pair like 2 into 3, that is 6. So you put root sign here. Okay, again we try another example. Suppose this bracket root 2 plus root 3 and another bracket root 2 minus root 3 is given here. So you use the concept of identity also because we know that here a plus b and a minus b. But you don't know the identity of a plus b, a minus b, then how you try for the multiplication this number. So first you select this number root 2 and you write down with the second bracket root 2 minus root 3. Okay, you select the second number with sign, so root 3, and now your second bracket is same again, root 2 plus root 3. Okay, then we have root 2 into root 2 minus root 2 into root 3, and similarly root 3 into root 2 and minus root 3 into root 3. Okay, so you have like 2 into 2 here, then minus 2 into 3 plus 3 into 2 and minus 3 into 3. So here again we have the pair. Again we have pair here. Then this root sign remove here. So you have 2 only. But here you have root 6. Similarly you have root 6. And now again pair here. So root remove. And you have 3. And now but these two terms they have the alternate sign. So they are cancelled out. And now rest of the term is 2 minus 3. So your answer is minus 1. Okay. So you have the two brackets like rational numbers form of in pairs. You multiply, you simplify, and then you got the answer as a minus 1. Because before of this we learn about the concept of like addition and subtraction. So here we simplify, after simplify we write down the answers. So again we take another example like with the different pair root 3 plus root 5. Okay, and then another bracket having root 2 plus root 7. Okay, so there is no number is common now. So again you multiply the same. You choose the first bracket of first number and put second bracket as it is root 2 plus root 7. Okay, now we consider root 5 because first bracket having the two terms, so these terms you write down separate with the second bracket, and root 5 you put again as it is root 2 plus root 7. So you write down here root 3 into root 2 plus root 3 into root 7. Similarly root 5 into root 2 and root 5 into root 7. Okay, so here we multiply 3 into 2, again same 3 into 7, again we have the different pair of digit 2 5 into 2, and last we have 5 into 7. Okay, because this they are separately given. Now we multiply, then we put inside a number. Now there is no common pair, all term having the different digits. So 3 2s are 6, you put as it is, 3 7s are 21, 5 2s are 10, and 5 7s are 35. If you find out mixed fraction, then there is no common pair there. So your answer is this. Okay, so multiple variety of the questions here you apply, you do the practice, and you multiply and you got the result. Because simplified questions also you have the same pattern. With different category of the questions you have choose in the bracket. You also have the outside value in the numeric form, like because these examples we consider as a pure search form. Like maybe another example you consider here, suppose 2 root 3 multiply by 3 root 2 minus 4 root 3. Okay, then what happened? This number you multiply inside, so 2 root 3 multiply by 3 root 2 minus 2 root 3 multiply by 4 root 3. Okay, so outside value multiply outside, so 2 into 3 outside, and inside value like 3 into 2 you multiply inside. And now 2 4s are 8, so you put 2 into 4, and like root 3 3, so you put inside 3 3. Now here you have the pair. So 2 3s are 6 and root 6 minus 2 4s are 8, and now this root are removed because they are completely in the form of pair. So you put as it is, so 6 root 6 but with minus 24. So this simplify, this term also you multiply in this form. So many examples you take here in form of the multiplications, because multiplication is also very easy. Because if you try 8 examples and you also try many more examples with the different category of the numbers, different category of the brackets, you maybe choose in the form of the rational numbers, and then you simplify all this, you got the result very easy, because you know the concept of pure search, mixed search, operation of addition, operation of subtractions. Then you go through the operation multiplication, then your multiplication operation